Good evening, everyone. Welcome to the Architecture 211 Concrete Inspection class for Saddleback Community College, spring of 2026. The concrete course that I teach, the book material is in front of you right now. It's a book called Concrete Manual, and there's an ICBN number for the book. It's published by International Code Council, ICC, that also provide exams for inspectors and contractors to get certified. So it's a valid book. It's a good book. If you can get a copy of this, maybe used or to other students, I would highly recommend. It's a good book to have. And concrete is one of those very primary materials that we use almost in any kind of construction, from a single family home to a garage, to a driveway, sidewalk, all the way to parking garages and high rises. Concrete pretty much is used in every job, one way or the other. So having the knowledge of it is a good thing. The presentation that you will see in this course from me is made based on that book, but I've added things to the class as well. Tonight, we're going to talk about fundamentals of the concrete and give you some basis of what I refer to in a simple language, a soup. Concrete is a mixture of 5 elements that you mix it with the water when it's liquid, and it starts to harden due to the heat of hydration and due to the chemical reaction. Basically, concrete is made of gravel. You may want to jot down these 5 things because you're going to hear this from me again. Gravel, sand, cement, which is the glue, water, some air, and some pozzolans. Pozzolans are the chemicals that we act for the concrete to cure faster, cure slower, and very little amount of that is normally entered to make concrete. But bulk of concrete is gravel and sand.
Professor, sorry, what was that last component? I didn't quite understand.
Pozzolans. Pozzolan.
Pozzolan?
Yes. Those are chemicals that we add, if you're building something in a sulfate area or salty areas, we may add some chemicals to the concrete to make the concrete more to provide more strength, to provide better ability to endure some severe soil conditions or weather conditions.
Hey, Professor, I'm sorry. Do you mind spelling the last thing?
Pozzolan is Pozzline, pozzolan. You will see
All right.
it through the course. It's going to come in.
All right, thank you.
The chapter 1 of the code is basically, as you can see in front of you, it talks about history of cement and concrete. By the way, cement and concrete. Concrete is a combination of those 5 things that I spoke about. Cement is one of the elements. Make sure you understand. When we talk about concrete, we're talking about combinations: gravel, sand, cement, water, pozzolans, and some air. That combination of 5 or 6 makes concrete. But one of those elements of the 6 is called cement. Cement is the glue. A lot of people mix cement with concrete. So let's make sure we understand the difference. Cement is the glue that makes the gravel and aggregates and everything else adhere together. to become like a rock, to become like a concrete. When you mix these chemicals together, to you, maybe dirt, sand, and rock, but there's a lot of chemistry and chemicals involved. Like any other chemical reaction, it creates heat. When it creates heat, it cures itself and becomes strong. So as a result of this chemical reaction, concrete find different characteristics. Some concrete harden fast, some concrete slowly hardens. So after many years, contractors, the concrete people have figured out how we can provide concrete for different usage. When you mix the concrete or you try to mix the concrete, the water cement ratio is the most important thing. It's like a soup. If you add too much water to it, it becomes soupy. The soup does not taste good. If you do not add enough water, it's sticky. It doesn't cure. So right off the bat, you got to understand that the water is as important to the concrete as the cement. The glue gets created by mixing of the water and cement.
Professor, can I ask a question? In terms of the water, can you just use regular, like city municipal water, or do you have to have like a distilled pure
City
water?
municipal water. You don't want to use the creek or ocean or lake water because they contain salts. They're not clean. But city municipal water is good to make concrete. Good question.
So it doesn't matter about does the water hardness matter in terms of some air like back east has soft water, here we have hard waters. Is that
Water generally contain salts and different chemicals. For instance, if you are building something next to Colorado River, you can't get your water from Colorado River. You have to tap into the domestic water in that area because, like for instance, in California, we get our water from two sources, either through Colorado River or we get our water through wells. Most of the water that we drink or we use domestically comes from those two sources. But those two sources are not clarified or purified to a point that are good for domestic use. So city water is a proper water to be used in creation of the concrete because it's relatively inert. What you want to avoid is river water, Colorado River, lake water, and any water that could have contaminants in it. We will get to all these chapters, all these topics in full detail. But tonight I'm providing you a summary. Somebody else asked me about pozzolan and role of admixture. There is an assortment of admixtures that you can add to the concrete to make the concrete different colors, to make the concrete cure faster, to make the concrete cure slower, to make the concrete become stronger against the snow and severe weather. Remember, concrete has been around for 200 years, and contractors all over the world use that material. From Russia to Siberia, to Iceland, to Mexico, South America, Africa, Middle East, everybody uses concrete. So as a result, there's a lot of knowledge about the concrete. I have to also say that some countries cannot produce their own concrete. They don't have sand. They don't have the gravel. You'll be surprised, some countries, by the way, the sand that I'm talking about is not a sand you can go dig by the beach. Like in California, we have a lot of sand, beachy sand in the beach. That's not the sand you want to use in concrete. You may be in Middle East, in one of these islands like United Emirates. You're on sand dunes, but you can't use that sand. Sand that we talk about that gives you high strength concrete is a specific sand that goes through certain sieve and has certain sizes. If it's too powdery, too smooth of sand would not cut it. We'll get to all this discussion. You will, beside concrete, you will have a pretty good understanding of these 5 or 6 materials. So you don't go dig up sand at the beach to make your concrete at your home. You may live by the beach, but that's not the sand you want. Same thing, you may live in Saudi Arabia, where this all sand dunes and desert sand. That's not going to work for you either. Because, yes, you can make concrete, but that concrete is not durable. It's not the concrete that stays around 50, 60, 100 years. I will show you a bunch of videos in this class, especially maybe in 2 weeks, that shows you the first things you need to know if you are doing a concrete slab yourself. Before we get too heavy with concrete structures and concrete buildings, it's not that simple to put a good sized slab, making form, pouring the concrete, finishing the concrete. These are all skill sets and you need tools. We'll go through videos with all those. But there are 5 points that are fundamental in any concrete work. Before you do any concrete work, before you bid a job, before you inspect a job, you need to go to that job site and look to see if there's a high water table, is there sulfate, is there a clay, is there a river running next to it, is it the rainy condition, is it Chicago and cold weather in February? So you got to go to the job site, and each job site is different. So don't bid the job. Don't say you know that you're concrete if you do not know the territory, if you do not know the area, the land. Next thing you got to be aware of, concrete for different buildings are different. If I'm doing a regular slab, maybe I use a 2,000 to 2,500 psi concrete. But if I'm doing a high-rise building, I'm going to use 6,000 psi concrete. If I'm doing a parking garage, 6,000. If I'm doing a nuclear reactor, 12,000. So beside the site, you need to know your structure, what you're building. You have a picture in front of you. You see this building in chapter 1? What does this building looks to you? Can somebody tell me what this can be? What is this can be? Is this a regular concrete, or could this be a prison?
I was going to say a church, but it could be a prison too.
Yeah,
gonna say
this
an
could be a
office.
prison, this could be a
Yeah, I was gonna say
data
office
center, this
buildings.
could be a military building, but this is a class of architecture that was very popular all over the world between 1990s and 1950s or 60s. We have a lot of buildings like this in California. City Hall of Long Beach, Library of Pasadena. These kind of concrete structures were very fashionable at one time, but not anymore. People don't like these things, and they're sort of demolishing them and rebuilding them. These kind of buildings leak a lot in the long run. You will get to know all that. So beside the structure, you also need to know what is materials are available to you. Let's say you are building something in an island of Fiji, or one of these islands in Europe. There's no Portland cement there. You have to import the Portland cement. So you may have to order a ship to come in with the Portland cement. You may have the rock, you may have the sand, but you don't have the glue. All that glue has to be shipped. So in making a decision to build concrete, location, material that are available to you is very important.
So, Professor, this cement, is it a fairly complicated mixture itself?
It
Because
is.
concrete seems pretty okay.
I'll explain to you. People think it's easy. People is easy. They think they may never think enough that, boy, building a high-rise building in Seattle is not just a job for an average Joe. I'll show you a video on a high-rise that we built in Long Beach during this class, that you see how much skill it takes to build a concrete structure. To make forms, wood forms, to build a shape like this, you may have to industrialize it. You may have to do precast concrete. One night we talk about precast concrete because you don't have time to form every piece of concrete in this building, but you can make every piece in the shop, in a building, and put it in the back of a 18-wheeler and bring piece by piece to the job site and connect them together. That concept is called precast concrete. A lot of buildings are done that way all over the world. We'll get to it. So one night we're going to talk about precast and post-tension and all these techniques that are used in erecting a building like this, in building a building like this. Next level that you need to be careful about is, okay, let's say you have all the material and you have the money, but you want to build this thing in a resort. You want to build a concrete resort building in Nairobi or Iceland. There may not be enough crews or concrete people to build that in those little islands, those places. You guys have recently seen a lot of videos on TV about Greenland. Have you seen that? What Trump is trying to do? You don't see too many concrete structures there. You see a bunch of wood stick frame. Why do you think is that? Because that kind of a skill set or that kind of money did not exist in Greenland. You see the smaller structures, but you don't see a high-rise building like you see in Chicago, in Greenland. Greenland from Chicago is probably 5 or 6 hours. It's not far. But the skill set is not there. The skill set is in Chicago. So if you want to build something like that, you got to go to get the guys to come from either LA, Chicago, Mexico, or somewhere to go out there and build it. So do not underestimate man, workmanship, and equipment you need to do that. And lastly, let's say you build it. Like anything else, requires maintenance, requires take care of your structure. That was the introduction. But let's see what the old timers have done with concrete. In as much as I scared you, I told you the things you need to be aware of. Concrete has been around from all over the world since Mesopotamia, since old Greek times, since old Persian times, Egyptian times. Every one of these societies or communities built their own concrete. In Iran, we call it saruj. In Egypt, they mixed it a little differently. But what they knew, if you get some kind of a gypsum, some kind of a clay, some kind of a sand, and some kind of water, and mix it and heat it, it cooks, becomes strong, becomes solid. So they made adobes like this and turned fire inside them. So it glazed itself. Or you can see structures made of some kind of a concrete material in Peru, for instance, in Mexico, in Egypt. So similar material that made from the earthy material with mixing water, you see the sign of it from centuries ago, 3,000 years ago. Then time came for Greeks and Romans. Beginning of the Western history. Those of you who have been in Rome, this is the oldest, largest concrete dome, Pantheon. Have you seen this? Some of you have seen this. Yep, still out there is a waffle roof, waffle slab or waffle dome, but it was made of some kind of a concrete materials between the rocks, and I don't know how many years that is, but it's one of the oldest, one of the most famous domes of the world is this puppy. I guess there are 5 famous domes in the world. Hagia Sophia, Pantheon, St. Peter, Duomo in Florence, and Dome of the Sistine Chapel, the dome in Rome. So those are the 5 big domes, and this is one of them. This is inside of a Pantheon. All concrete, some kind of mixed concrete, because this is not stone. But in order to make it lightweight, they made it waffle shape and build it. And this is 3,000 years ago. So what I'm telling you, what I'm trying to teach in this semester, something that has been around one way or the other for centuries. Most recently, as we start navigating the oceans, shipping became important. Humans realized that in front of the force of the water, oceans, concrete works the best. So you see a lot of lighthouses that are still standing that they initially were made with concrete. You see them all over the world. Some standing, some are damaged, some are historic. But lighthouses came in as a result of they were starting to build them in 1700. Then somebody with the name of Joseph Aspidine, this guy was a mason guy in England. Very much like, you know how British people, they take something and they learn from other people and they purify it. This guy took the aggregates, he took a pure clay, he took pure sand, he took pure gypsum, mixed it with water, heated it, grinded it, and patented it as a Portland cement. Greeks couldn't think of it, Egyptians couldn't think of it, Romans didn't think of it, but somewhere along 1800, this man from Portland, England, not Portland, United States, invented what we call Portland cement. And after patenting it, of course, he went through testing to figure out a strong combination. He called it Portland cement. And for years, it was his monopolized because he could build buildings like that. But like any other patent, after 50 years expires, then other people in the world, they learn about it. So by the turn of 1900, this was a public information. At one time, this Portland cement was like a AI of its own time. It's a iPad or invention of its own time. But as people all over the world, the technology travels quite fast. French people learned it, European people learned it, Russians, Germans. As a result, they built their buildings strong in Europe, and that technology or that knowledge traveled all over the world. So that's a little history about how Mr. Aspidine is, or Aspidin. He basically took pure limestone, which is lime. He took chalk, clay, gypsum. He added water to it, and when you add the water and you mix it and you heat it, they become clunks. And then he powdered that clunk. He grinded it. It turned out some gray material, gray color. That's what now you can put in sandbags and sell it as a cement, Portland cement, and that's your glue. So this was 1840s or mid 1800. By that time, US was discovered. By that time, migrants were all coming to Europe, to US. Cities like New York, Buffalo, Chicago, Detroit, right around the Five Finger Lakes, they were becoming big city, immigration all the time. Both people brought people from Europe, and people start living in these cities. Buffalo, Syracuse, all this, Boston, all these cities came about. Beginning of the United States. The pilgrims, they need a housing. They need to build their homes. Very much like right now we are doing in California, everybody's building homes. Then they were building homes all over back east, and they need lumber. Lumber was in Canada and other parts of the US. So in order to ship lumber to New York, in order to ship lumber to Toronto, in order to ship lumber to Boston, they used the Great Lake and river called St. Lawrence River. What they figured, if they connect these lakes together, from one end of the lake, you can start sending wood, all the food, all the stuff that you need between Boston and New York ports, all the way to Chicago, all the way to Detroit, all the way to central United States, and vice versa. Gets cheap goods from there, bring it to the big cities. So shipping started, but it required for them to connect the lakes together. So in order to connect the lakes, they need levees. That's where the use of concrete in the United States started. One of the biggest reasons that concrete got developed and became big part of US economy at the time was building these locks that would connect several lakes together and connects the lakes finally to St. Lawrence River. And St. Lawrence River, for those of you who have ever been there, goes all the way to Ottawa and Quebec. So it also connects Canada. It connects to Pacific Ocean or Atlantic Ocean in Quebec area. So this way, through Five Lakes, through Niagara River, they had to build all this concrete. And this profile that you can see, as my cursor shows, is the difference of elevation that they had to work to be able to get all the way these locks connected. You see, they are not at the same level, but you know how the lock system works. And you see these barges. For many years, these barges traveled through the lakes, Detroit, Michigan, Buffalo, all these cities they were the industrial hub of the US at the time. They were able to grow and support US economy just because of that waterway. And the only way to build that waterway was concrete. Nothing else could have done it. So this was a little bit about the history of the concrete, where we came from, how it was invented, how it came to US. And this gets us pretty much to First World War. Then the attention changed. People went after the wars, and then the economy went down in late 1920s. But people still had to build. People still had to make living. So since then, a whole bunch of new technologies came about that we build our buildings. For instance, one of the things that we're going to talk about this semester is slip form. That's how Canadians, Chinese, they build their concrete buildings. Let's say you want to build a 50-story building. You can build a form, dismantle it, and build the next floor, next level. But what you do, you build a form, you pour the concrete for the first level, then you shift the forms. So the forms on the second floor for a while are supported by the concrete that you poured on the first floor. When the second floor is done, they shift the forms to the third level, and then they pour concrete. So it's called the lift or slip form. They slip the forms up the height of the building. For instance, the Burj of Dubai, which is the tallest concrete building in the world, that's how it was built. I'll show you more pictures later. Another thing that we do in California that's very innovative is tilt-up wall, tilt-up buildings. Who is not familiar with the tilt-up wall? Or who is familiar with it? Samer doesn't know. Anybody else know what the tilt-up wall is?
Yeah.
Go ahead. William, do you know what it is? By the way, unmute yourself if you don't mind. What is tilt-up wall?
I don't know. I assume it's pouring the concrete flat and tilting it up to the.
Exactly. Who wants to explain this better to the group?
It's usually commercial grade applications for industrial complexes. It's where they uh, frame up some forms on the ground and then they pour the concrete on the ground on the site, and then they use a crane to tilt up the concrete slab in a sense, which they'll then place on top of the existing slab on the wall. So it's technically they build it on the ground, form it on the ground, and then they tilt it up, and then they place it in place for the wall. That's why you see like all those lines on a commercial grade, like industrial complex area.
Very well said. At
Thank-
this time, I need you guys to know what the tilt-up is, or make a note on your notepad. We will get to it down the line during semester. I'll show you either video or a full-fledged tilt-up building. You will become familiar with all these terminologies. But tonight, I'm just breaking the ice on you guys. I'm just going through some words, some names, some materials to make you familiar with the concept. You heard a little bit about precast concrete from me already, so you should have an idea what precast, pre-stressed means. Then a lot of people want to do white concrete. Yes, you can now do a white concrete. Very expensive, but you can do it. The concrete on expansive cement, sometimes you want to have a concrete that can expand and contract. So you can make your concrete plasticky. So it has got the plasticity to it. It's used for slabs, it's used for a lot of places. Color and texture, the whole world is out there. You can, when you drive along freeway, for instance, have you seen bridges with embossing of the birds or decorations? you can really get articulated and very sophisticated with your concrete. You can bring concrete into your office. Later on, I'll show you a use of the interior concrete, how you can add different finishes to the concrete. You can add different motifs, different shape, forms. So concrete is not that old, gray look, ugly look anymore.
Thanks to CNC rigid foam detailing, they can just CNC the negative and set it inside the form, and you got birds flying and everything. And the CNC machines just do all the artwork. Well, somebody does the artwork. They CNC the mold, and then they set it on the inside of the form.
Correct. But you need to have a proper concrete, so all of a sudden you don't have a big rock in the middle of the bird.
Mm-hmm.
So you have know your mix if you're venturing that far. So I'm going to seek as a project for this semester, somebody's going to work on bringing that knowledge to this group. Concrete that could be used for interior sophisticated finishes. So if it is your forte, or if you're something you like to grow into, could be somebody's project this semester. Then we get into lightweight concrete. Write this down because it's fundamental for you to remember. Concrete weighs about 150 pounds a cubic foot. When we estimate concrete, when we have to have a feeling for the weight of a concrete. Average normal concrete is 150 pounds a cubic feet. Pretty heavy. You must be mad to be able to lift 150 pounds. I cannot lift 150 pounds. How many of you guys can lift 150 pounds? Can I see a raise of hand? Ramen is in good, healthy shape. Matt, can you do 150?
Oh, I can do 150.
Good man. Damer, how about you, 150 pounds? Yes, no, Louis, how about you? Mina, how about 50 pounds? 150. Good man. You guys are in good shape. Travis, 150? Boy, you guys go to gym. You guys, Louis, what about you?
Probably I won. Yeah.
Yeah, all I can say, I do not recommend that to myself, and I do not recommend it to Emily.
You
Well,
only said you had to lift it once. Nobody said I had to lift it twice. So
right.
So here's I'll say one quick little story. I got to tell this.
Go ahead.
Cement bags. All I was doing was patching the floor. It was a remodel I did, and I cut out the floor to run the vent and the gas line to the island, right? And some others. So I just had a little cut, and then I had took out a window and had French doors, so I had to put in a little stoop, like a little walkway to connect. So it wasn't much cement, but it might have been 8, 10 bags or something like that, of 90-pound bags. And so I was doing the whole job myself. Every once in a while, I would just like do a little job, and I do everything myself. And so I broke out the concrete, I did all the stuff, and I went and bought the bags, carried them into the backyard. I put them in a wheelbarrow, but I was carrying, lifting them, breaking in the wheelbarrow. And then like a week later, I was having these problems. And I got a hernia. And I had to have surgery.
Yeah, it's common in that industry. Yeah.
Yes. So I don't recommend it to myself and Emily, and I have done a lot of those crazy things when I was younger, but it's not a matter of the first time or second time you do it. It's a long run effect on your back and your spine and all that. But again, you need to do some of it. I'm not saying don't touch it. You need to do it, especially when you're young. It develops appreciation for you, I mean, your mind, and it makes you better person, a better engineer, or better knowledgeable person. Because if you have to put people to work, then you know what misery you're putting them into, and as a result, you may be a better boss. So I'm getting sideways, but it's important for me to make sure that you understand 150 pound a cubic feet. Keep that number in your mind, because if you're trying to understand materials, construction, you have to have a feeling for the weight, volume. This is not something that you can just pick and put it on top of the table. It's not that kind of material. Well, let me ask you something else. 150 pound a cubic feet. What about if you're doing a high-rise building? You know how heavy that thing gets? You talk about billions of pounds, billions of. Now, if I can get the concrete to 110 pound a cubic foot, is that good? Human being has learned how to make strong concrete by using special lightweight aggregate and bring the weight of the concrete to 110 pound a cubic foot. That's what we call lightweight concrete. It's still heavy, it's still 110 pound a cubic foot, but your building all of a sudden is 1/3 lesser weight.
So, Professor, is it done with the same materials that you told us in the beginning, or there's some other type of
The
newer
only thing
material?
that I change your gravel. You know what is
Pumice.
what is that?
Pumice.
Pumice. You know what pumice is? That's the word I was looking for.
Mhm.
Ramin, do you know what pumice is? Sangepa. If you get pumice, which is from the volcanic rock with a lot of holes, that kind of a stone, that kind of material is very strong because it came from the Mother Earth. It came from the bottom of the earth. But because of the chemicals and oxygen and all that, it has a lot of holes. It's a very lightweight, strong aggregate. So if I want to build a Burj of Dubai or Empire State Building or something that's going to be extremely expensive, I need to use lightweight concrete. So lightweight concrete is used on the floors, very popular. We even build custom homes in California, and we put 3.5-inch lightweight concrete on the floor on a very custom homes, or inch and a half, I should say.
It also has a higher fire rating
Correct.
too.
So we'll get to all that, but Matt said something that's also quite critical. We use concrete when it comes matter of fire rating. You heard from me that concrete gives you the strength, the structure ability, structural potential that other materials don't have. But it also gives you fireproofing capacity that other materials don't have. So concrete has got at least 2 pluses versus the wood. Stronger than wood, more fire rating than wood. So small buildings, you build it with wood. But when you have to deal with a large building, that the fire rating is important, large number of the building, you lean towards concrete. And then when your building grows and becomes taller, let's say 3 or 4 story parking garages, you use the regular concrete, strong concrete. But if you have to build a very slender, ductile, high-rise building, then you use the lightweight concrete. And you heard the word ductile last week from me. I'm going to say it one more time. Ductility is like a tree. You know how the tree moves in case of earthquake and doesn't collapse, but building collapse? If the building does not move, it's too heavy, it's going to collapse. So buildings have to be light as possible. That's why you see a lot of collapses in Turkey and Italy and other parts of the world, because they didn't have this technology that we have here. Now our buildings don't collapse. Then we get into reinforcement, welding, glues and epoxies, how to make old concrete projects or buildings resist rain, I was in a conversation with an attorney today on a parking garage that's leak and has got cracks all over it. How to repair it, how to fix it. A big job for Caltrans, a big job all over the United States. US infrastructure, bridges, dams are all getting old. They all need maintenance. They're all majority made of concrete. So concrete repair is a big industry, big job, especially if you're in Boston, Chicago, cold country. We see concrete work in LA area all the time, but it's not even a token in compared to the concrete companies and concrete repair work that happens in a cold climate back east or central US. So if you ever travel there, if you want to get a job, those are the fields. A lot of Dominics and a lot of Italians and Polish people. Entire New York State, concrete workers. Now I mentioned technology and tilt-up. William, this is what's called tilt-up.
Yeah.
The entire Ontario, the entire city of Irvine, the entire Mission Viejo, city of Santa Ana, commercial industrial areas. That's how we built. They can build this thing 40 feet high, 6-inch thick. You can never build a wall 40 feet high. Like what you see here is about maybe 24 feet high. They can make this twice as tall, 40 feet, 6-inch thick. Only material that allows you to do this concrete tilt-up. And they put sand, they lay them on the ground, no form work, very little form work. They wait 7 or 8 days. When they cure, they bring the cranes, they lift them like a jigsaw puzzle and tie the tops and tie the bottoms and becomes a tilt-up building. Becomes Costco, becomes Home Depot, becomes buildings that you go do your shopping all the time. Another thing these are, by the way, technologies of 1970s in California. When they started doing this in California, they were not doing this anywhere else in the world. So what you see in front of you are inventions. The guy who built the tilt-up, I used to work in 80s, I used to work for a guy, William Simpson Associates. That's all he did. He all built tilt-ups all over and become a billionaire. He has an office of like 40 people. I was one of them. We used to design this with a wood ledger. And because they were going up quick and the architect engineer gets paid per square foot, he made a lot of money. To this day, big companies built these warehouses. When you travel, as I said, the entire city of Ontario, as you drive 210 going towards Palm Springs or going towards Vegas, you see this thing being built all over the place. Another technology that I refer to as a toothpaste is K-rail. There are machines like this that they put concrete mix in it and very much toothpaste. As the machine moves, it produces K-rails for the middle of the freeway. No formwork, nothing. And this machine moves up and down, goes on curve, and these K-rails, the toothpaste, come out shaped, curvy, linear, straight. So these are all very, very sophisticated skills, and only certain contractors do this kind of work.
So, Professor, how long does that take to harden if it's just coming out and they're putting it on the road?
Samir, ask the question louder. I can hear you.
I was asking, how long does it take for those railings? How long does it take for them to harden? Do they
Oh,
harden
this gets
instantly, or-
hardened within hours.
Really? Okay.
Yes. Now, when we talk about puzzlings and accelerators, you hear from me. We talked about puzzlings tonight. To make something like that, and for something like this not to slough off, not to be a soupy toothpaste, it takes a lot to do this.
Isn't that also how they do curbs, like on
Yeah,
a
they make a
scale?
curve shape. Yeah, they do.
Yeah.
These machines work with the computer.
Mm.
These machines don't have a regular operator.
So
You
this is
give
how
it
they
a
do this.
software, and the software runs the wheel, runs the gadgets, everything, and it go ahead and pour 100 linear feet of cable.
Professor, this is how they use the like so they have those large 3D printing machines that print buildings in China. This is the technology that they use?
Yes, that is for the buildings. We'll talk about that also, but this was the beginning of that. This was easy to perceive because you got one shape to make for miles. So if you invent a machine for that, you make your money. But what you see in China or Germany, that we call it concrete for homes,
3D printing
3D printing,
concrete.
yes, home 3D printing.
And they do it here. They're doing it in Arizona. There's already tracks going up here with
Yeah,
it.
I haven't seen it yet, at
Yeah.
least in agencies that I have worked for, but I'm sure there you can find them here and there. It's coming.
Yeah, it is. It's already, yeah.
More advanced type of concrete that you're going to hear and become familiar with, this is called post-tension. You pull tendons, you put them under stress, and you pour concrete, and concrete grabs these tendons. These tendons work like a rubber. They put stress into the concrete and keep the concrete not cracking. You can have precast concrete. This is precast concrete. Let's say if you are doing a drain channel in a cold country and you only got 2 months of summer to build it. You make these forms in the shop during winter time, and then you put them back off the trailer and you bring them, and you have your people with gaskets connect them together so they don't leak. Then it works like a flood channel or water channel or something.
Professor, is pre-stressing the same thing or the opposite of post-tension?
Precasting is not post-tension. It could be both. Post-tension is where you are inducing a lot of strength into the concrete.
Okay.
Precasting is for shape. Let's say you want to make a swan with the concrete. You want some very peculiar concrete shape. You can make a form and precast it and bring it and put it on the
No,
side.
I didn't say pre-casting, I said pre-stressing. Is that in
Pre-stressing and
line with
post-tension,
post-tension or
two different concepts. Very good point. One, pre-tension, you pull your tension and then you concrete afterwards. Post-tensioning is concrete is poured, then you come grab the rebar and push it, pull it. One is you induce the tension before concrete is poured. The other one is you induce the tension into the rods after concrete is dried, cured. Post-tension and pre-tension.
Professor,
Can I
this
interject?
is counterintuitive to me. Sorry, just real quick. If you're putting tension into concrete, wouldn't that cause cracking or wouldn't that
No,
cause
no, no.
issues?
Concrete
Can
is
I
weak in
explain
tension.
this?
Concrete is
Can I-
weak in tension.
Yeah.
Concrete, if you make a cylinder of concrete and you go stand on it, nothing happens to the concrete. Concrete is good in compression. But if you get the concrete and start to pull it, the aggregates come apart. The glue comes apart. The strength of the concrete is in compression. Where the concrete is weak is tension. That's why you put rebar and you tension the rebar to induce tension strength into concrete.
Mm,
Am I
okay.
clear?
Yeah, no.
Can I explain this? Like, this
Yes,
is
yes,
just an
please, go for it.
analogy I use for a lot of people.
Go for it.
Yeah.
So the cables are in sleeves. The cable runs through it looks like PEX. It's inside and it's lubed up. It's got grease in it. So the
Okay.
cable moves freely inside of this sleeve. And that runs through, and they'll put one top and bottom or whatever, however they want to tension it. But just imagine taking a string with a stick on one end, a popsicle stick or whatever, and you put beads on it. So you pile up 10, 12 beads, and then tie another popsicle stick to that, and you start twisting that so that string gets tight. As it gets tight, it pulls those beads together, and at some point, those beads are going to get rigid as it gets real tight, and it compresses those beads together. They're going to become stiff. And so that's what you do with a slab is after it cures a bit for maybe 10 days, whatever they specify, then then you will put tension on it. And they go up to anywhere from 30 to 90,000 pounds of force, of tension on those cables. So they're tension. That's why it's called post tension.
Okay. Thanks, Matt. That's a good analogy there. Thank you.
And this strengthens the concrete.
Now we talk about lightweight aggregate and type of the aggregate that you could use to arrive at the lightweight concrete. Humus. Concrete by itself, as our conversation are ending up, rely on a rebar. Steel gives it the tension. That's why we call it reinforced concrete. In California, you cannot build any building just made of concrete. You have to build reinforced concrete because you can pour a slab on grade concrete only. But anytime you want to build elevated walls, floors, has to be reinforced concrete. That means it has to have rebar. Now, rebar is a steel that has been remelted or reused. When you take your cars to junkyard, when junkyards are full of bad metal, old metal, they melt them, they make a rebar out of it, and they use it in concrete and they hide it somehow. So there's the economy here, but to create a deformed rebar, you have to have certain labs, certain skills. So your steel is good for 40, 60 KSI. So one night we spent all on rebar and understanding rebar. I mentioned there are 6 elements to the concrete, but there's 7th element in reinforced concrete. That's the reinforcement. It comes different sizes, different shape, different materials. You can get a deformed carbon steel, or you can get stainless steel as a rebar. Depends on what you're building. Most of the old concrete building structures, when they crack, the rebar gets powdery. Then it loses strength, the concrete starts cracking in tension. So a lot of bridges that are collapsing is because their steels are collapsing or becoming corroded. But if you are dealing with the concrete next to the ocean, you may want to use a special reinforcement so it does not corrode and is more prone to the salty water ocean. If you're building an Empire State Building, or if you're building Golden Gate Bridge, you may want to use a special reinforcement because you see this picture down here? This picture shows a cylinder of a concrete that the rebar is completely rusted. No bueno. This is not good. You can get it galvanized See, when it comes to rebar, there's sort of assortments of rebar or materials that you can use, become very expensive, but depends on what you're trying to achieve. From stainless steel to galvanized steel to regular 40, 60 KSI steel.
You know,
All that.
Professor, I've seen that plenty of times doing various concrete demos, the rusted rebar. Is there a way to prevent that? I mean, considering how old the concrete may have been.
Again, one night of these 16 nights, we talk about concrete repair because it's a paradigm across concrete industry across the world. If you're in Germany, you're going to be dealing with it. If you're in Slovakia, you deal with it. If you're in Toronto or Chicago, even parking structures in Palace Service, you're having trouble with this man. So yeah,
Professor, do they use or have they considered
there's
using
there's a
Roman concrete?
there's a fiber reinforcement panels that is used to, because when the steel is rusted like that, you can't do anything to it. It's in the middle of the concrete. You got to come in and scrap the concrete with other materials. Let's say when you play sports, when your knee hurts, what do you do to your knee? Can I ask you?
Wear a compression brace.
Exactly. Same thing with the concrete. When the concrete goes bad, they have materials that protects that joint or that concrete from outside. So you talk about fiber reinforced concrete, fiber reinforced materials, epoxies. There's a whole universe. There's a whole bunch of companies. That's all they sell all over the world and make millions. They just have that knowledge. And you will become familiar with that. And if it's something you like to grow into, that could be your homework assignment. Let's talk. Here's a good example of why you need to become familiar with the repair of the concrete structures. Until I do not show you this picture, you may not take it as serious. But almost every bridge that we have, no matter where in the world, after 50 years, after 40 years, sometimes it's going to become like this. So they all get repaired. They all get fixed. Caltrans, State Department of Transportation, marine structures, all these federal and state government agencies that we have, they have a big budget on their structural repair. Hospitals, dams, sewer pump stations, water stations, any infrastructure. When you get pilasters like this, you see how they come and they wrap up the fiber reinforcement around it? This is that knee brace that I was just telling you.
Carbon fiber.
Fiber. There is engineering behind it. There is, they come back with the fiber, and the fiber come different thicknesses. Sometimes they apply it flat out. You see on this picture on the bottom, the failure was up here. So they went and put the fiber in here. If the failure is on pilasters or columns, you put it here. This is an example of the concrete bridge, could be in back east someplace or central US.
Surfboard repair.
What is that?
I said it's just like a surfboard repair. Just
No,
the
it's not
fabric, carbon fiber fabric and some resin, some epoxy,
and it's not California because we do better than this. We don't use heavy beams like this anymore. This is old construction, somewhere back east. Remember, we're only a state that's 100 years old compared to some other state that are 200 years old.
Mhm.
Well, concrete is used for high strength with superplasterizers, silicas. These are different admixtures that we add. For instance, how do you pump a concrete 100-story high? How do you get the concrete on a 60-story tall building?
Use a really long hose.
You either pump it or you use helicopter.
The
Seriously.
helicopter pumps it.
Or you use a lift. We'll go through all this. It's going to be an exciting semester coming up. But then when you become knowledgeable about your concrete, this is what the people are doing. These shapes are all built, pretty much. Then we get into high strength concrete. Hydration reaction. The reaction that comes as a result of adding water to Portland cement, it's a chemical reaction that connects all these particles and sand fills the holes. So there's a logic why you gotta mix sand with the rock, because that epoxy and water, it connects all the gravels, all the rocks, but because rocks have weird shape, sand fills all those holes. As a result, it becomes a strong composite. No matter what you do, there's still some amount of air will get entrapped into the concrete, and sometimes it's good to have air entrapped in concrete, and sometimes it's not. If there's air entrapped into concrete, the concrete becomes lightweight, but it becomes more porous, so the water can go through it. This cross-section shows you something fundamental that you need to realize. Aggregates should not be very smooth. You don't want river rock or shiny rock or smooth rock in concrete. A lot of places, let's say when you walk by the creeks, Covina, foothill areas where you have a lot of water runoff, a lot of rocks. I'm sure you have seen them. Are those rocks good for concrete? No. You don't want a river rock. You don't want a rock that has hit other rocks and becomes smooth. You want jagged aggregate that has a lot of corners, shapes, so it can glue and connect better. Smooth rock slips off. You don't want a smoothness. So this picture shows you there's no smooth rock in here. Remember, this is a cross section. They cut through it with this saw. That's what you see. But these were not, none of these are smooth rocks. Cement and water first come together, they become a paste and binds the aggregate and particles together. Okay. Water cement ratio. For the purpose of tonight, it's important to, at least for you to realize what it is, what it does. There's a magical proportion of the 0.44 pound of water per 1 pound of cement, or 5 gallons of water for 1 bag of cement. Contractors, the one that mix concrete on site, they know this. When you go buy a jug of milk from the store, a jug of milk is 1 gallon. I'm sure you have seen, you have a visualization of what 1 gallon is. So if you want to get a feel for what a good paste is, you get 1 bag of the cement, 94-pound bag, heavy, breaks your back. But you mix that with 5 milk jugs, water. That paste is a good, relatively good paste, has adequate water cement ratio. Just remember this, we'll get back to this topic later on. But 5 gallons of water for 1 bag of cement. Bag of cement, you can buy 2 types of cement, either 63 pounder or 94 pounder. If you're a lightweight contractor, your normal contract you go Home Depot, you buy 60 pound. If you're strong Gordo, you buy 94 pound. But what you need to know, water plays like a devil. You need enough of it, but if you put too much water, concrete does not become strong. Your soup becomes soupy. So in order to get strength to your concrete, you need to it's like a soup. Let's think of soup. You need to make sure the water is enough. Otherwise, no matter what you do, no matter what kind of beans you put in it or meat into put it, it's too watery, too much. So water, cement ratio is important. You already learn your the stuff you put in your soup, your rocks have to be granular. You learn your sand cannot have salt, cannot be beach sand. You learn about your water a little bit. So you can compose, you know enough now to catch somebody who is using river water, sand from their backyard, or rock from the river on their property to make concrete. Does this happen all the time? Maybe not in California, but guess what do they do in Nevada or Minnesota or places that you got big ranches? Everything is right in the range. You got rocks, you got the sand, and you got the river. Does it give you good concrete? No. Do you have to get them tested? Yes. You may have the right material on your land, and then you go sell that material. You don't have to make your land a park. If you know what you got on your land, you may have a good puzzles. You may have a good rock. You may have all these materials that I'm telling you, they are quarries and mines. I just read an article that somebody sold for $80 million a piece of land. Did you read that, by the way? The biggest piece of land was recently sold a few months ago in US. $80 million. The land is as big as the state of Vermont. It's one big range. It was all over the news. Well, the reason I'm bringing this up is your land, no matter where it is, you can have some kind of a mine. The mine doesn't mean it's copper or gold. It could be puzzles. It could be a quarry of rock. It could be a quarry of good sand. Then you sell it. People buy it and make concrete. There are traders, there are companies that's all they do. They trade rock, they trade sand. And who buys it are concrete companies, batch plants. When you order a truck of concrete, how much is a truck of concrete? You guys should know by now. 10 yards. Louis, what does the 10 yard cost you? Come on, buddy.
3,000.
How much?
3,000.
2,000.
2,000.
Last I heard was 2,000. So $2,000, 10 yards. There's at least $400 or $500 worth of rock in it. Couple $100 worth of sand in it, in one truck. So yes, you can make money on those. A little bit about the role of admixtures. By the way, do we want to take a break tonight at 8 for 15 minutes, or should I continue? We'll take a break at 8 tonight. I'll finish this one and then we'll take a break and then we come back to the rest of it. You heard about admixtures from me tonight. That was the sixth element that we want to discuss in this semester with you. What these admixtures do, they reduce the water requirement. What does that mean? We said water could be detriment to the concrete. Water can freeze. Water, even though it's needed for the glue, has some problems. That glue will freeze in Chicago. So there are equivalent of water that you can add as an admixture. It's not water. It has got higher freezing level, but it serves as a liquid. It serves to provide liquidity to your soup. Are they good? Absolutely. Is there a need for doing that? Absolutely. There are places that they don't have water. A lot of parts of the world, especially some islands, they use ocean water. They have to use the siltation basin to convert the water for domestic use. So conversion of the ocean water for domestic use is very expensive. Some islands do it. But sometimes you may find these agents work better for you. There are agents that if you add to the concrete, they create bubbles in your soup. Bubbles means air pockets. Air pockets in a concrete make the concrete porous. Is it good? Sometimes yes. One of the problems that we have in Southern California is long time ago, this whole area was all dirt, was not developed. Now is one big concrete area. Rivers, roadways, freeways, we create a lot of concrete areas. These concrete areas are not porous. All the rainwater through the storm drain goes to the ocean. It doesn't do any good for the local trees. So in order to cultivate local trees, good agriculture and all that, porous concrete can serve a lot. And now it's a part of the code that you need, like Caltrans or agencies that they pour a lot of concrete. By law, they have to use porous concrete. That by itself has become a science, how you can make a porous concrete that's strong, can take the weight of the tractor trailers, but at the same time is porous enough to let the water seep underground. We have become very sophisticated, ladies and gentlemen, in the last 20 years. So tonight you heard from me from the early civilization all the way to 2010, 2015 technologies. Workability in a fresh condition. When you want to do a good concrete, workability, making a concrete workable, is a notion that you need to absorb. If a concrete cures too hard, becomes hard too fast, or doesn't become hard at all, it takes years and ages, you're going to pay for the crews, you're going to pay for a lot of wasted time. So concrete, based on the use, has to be workable. In other words, give you enough time, 3 or 4 hours, to trowel it, to finish it, not too soon, not too late. We call that workability. That workability can be adjusted by means of adding proper admixture. Now we get into laboratory testing technologies that are not available in a little island off of Pacific Ocean if they want to do a resort. These technologies, these knowledges have to all be transported there. When in country of Dubai. They build all these high rises. The locals didn't know this thing. It all traveled from England and US over there. Durability to risk attack by weather and substances. Big thing. Volume stability, minimum drying shrinkage. When the concrete shrink, it cracks. Crack control is a big, massive thing. If you're doing let's say, a dam, you can't tolerate that dam to crack for 50 years. So you better do something to that concrete. That's why a lot of countries over there cannot build their dams, or if they build their dams collapses. Even in the US, we get that all the time, a lot of time. Levees fail all the time. 2 or 3 years ago, the entire city of New Orleans was under the water. New Orleans never came back. New Orleans will never become the old New Orleans anymore. So it happens here too. It's not just other parts of the world. When you add right admixture, your blemishes, your rock pockets, those things could be addressed. You can make your concrete more watertight and then good appearance.
Professor, can I ask a question?
Yes, please.
So what does it mean by entrain air? Right in the first sentence, it says,
What word are you talking about?
so to reduce water requirements and then entrain air. What do you mean by entrain air?
Good question. What happens if you add soap into concrete soup? What happens? What does soap do? Soap. When you go, you wash your hair with soap. What do you see between your fingers? What does soap do? Soap creates bubble.
Yeah, bubbles.
When you wash your clothes with some kind of a soap, or you use soap to wash your body, it creates bubbles, right? Am I losing you, or are you with me, Sebastian? I'm serious. If you add chemicals like soap into your concrete, it creates small bubbles in the concrete. That's called air entrainment. After concrete is hard, those bubbles stay in the concrete. Am I clear?
So why would you want those small bubbles in concrete?
Because your concrete becomes lightweight, because your concrete becomes porous, so it lets the water through it, and because aggregates don't rub against each other. In a cold climate, that concrete expand and contract without cracking.
Yeah, like makes it stronger.
Well, as water freezes, it crystallizes and expands, and so it gives it a place to go when it expands.
Yes. But they use soapy material. When I say soap, I mean like a chemicals that creates bubbles inside a product. You can add gas and get into the water and make a bubbly, fuzzy water. You can do that, the same sort of concept, to the concrete. And when the concrete hardens, it holds microscopic cells of air in it. These are not big holes. These are microscopic air holes.
So can you say that if you're going to deal with colder climates, you do want
Yes.
concrete that has more of these microscopic bubbles in them?
Yes.
Okay. All right.
You want a strong concrete with some ability for that concrete to expand and contract. That's why I use the phrase of soup. You can make soup 200 different kind of soup. You can make soup that is good to your stomach in a hot weather. You can make a soup that you only drink it when you go to ski resorts. Am I clear? Am I sort of yeah. These concrete, I'm going to say this and then we're going to quit for 15 minutes. Concrete is a natural species, man-made. So there is a lot of resemblances to the soup that you make in your kitchen, because that's man-made by some kind of aggregates. All right, let me see if I can pause the recording. All right, we are going to continue with the 5 fundamentals that I already mentioned. Now you know the importance of why you need to be familiar with your site before you make any decision with your concrete. You need to be aware of what you're building, the nature of the building, loads, type of construction, the nature of the building. You need to be aware of what materials and mixes are available, where the batch plants are, where are the materials available, and where are the crews and your resources, tools, equipment, lift, cranes, pump machines, batch plant locations. They all become important. When you order concrete, the concrete cures very quickly. When they put it in batch plant in a truck and it's coming to your job, probably should not be more than 1 hour. But what happens if the concrete truck gets into the traffic and sits in the traffic for 4 hours? Is that concrete good anymore? No. So that's why the timing of concrete pour, normally contractors do it early in the morning, especially if you have a big jobs, you line up your concrete to do it one right after each other. There are times that you call the batch plant and the batch plant says, no, we don't have concrete available because we got 10 bigger jobs than yours. So be prepared for all those resources and logistical things that can come up, that you don't either get your concrete or workmanship is not available. What's the point of you getting concrete when your crews are not there? So there's a lot of things on stake. Let's say you have a crew of 5 people coming to you, do your driveway, and you have ordered your concrete. And these 5 guys coming from Riverside, they have a fender bender or one of them, something happens to them, flat tire, they don't get there on time. But these are all the issues that we need to be careful as a contractor when you order this concrete.
So, Professor, let me ask a question then. So this
Yes.
is assuming that the batch plants you're working with need to be, say, an hour away from you. But what if you have projects that the nearest batch plant is 8 hours away? It's in the middle of nowhere. Then how do
Excellent.
you handle that?
It happens all the time. Let's say if you're building a prison or some kind of a power transformer in the middle of Arizona desert. It happens all the time. You may have to establish a concrete batch plant near your facility, your operation. A lot of major community projects that they have, let's say 100 buildings, 200 buildings, they bring in the concrete plants next door to them. If you're doing a big roadway jobs or bridge jobs, you can't rely on companies to provide you concrete. You set your own batch plant and your own concrete manufacturing. If you are one of these third world countries or you're building let's say, a resort in a island someplace, which happens all the time, you will establish your own batch plant and you import all your materials and you mix on the spot at the location.
So, Professor, this is kind of like off the 55. They're widening around Dyer. Is that what those things are? There's just I remember something a while ago. Is that what
Yes,
it is?
that's not it. No, 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 no,
Ah,
no, 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 no. Let's go
no.
one by one.
Okay.
What you see along the freeway is old concrete recovery. In other words, when they take down a freeway or they want to repair a freeway or a bridge, there's a lot of concrete that gets demoed. They do not send this demo stuff 50 miles away to a place to convert them to rock aggregate. They convert that concrete right on the spot. They make their gravel. They bring a rock crushing machine and crush the concrete, and they produce their own aggregate. Not aggregate for the concrete, aggregate for the subbase. Because wherever you pour concrete, you need to reinforce the dirt. First you put rock, then you put concrete on top of it. Concrete still comes from batch plant, but what you see along the freeway is a rock crushing machine that crushes the rock so they don't have to pay for transportation off the site for the rock. They grind it, they shape it to the size that it needs to be, and they use it as a base material for the freeways, roadways, whatever they're building. And that's also not a part of California Green Building Code and recycling. You're obligated in any construction job to recycle 40% of your material. If you're doing your home remodeling, if you're doing a bridge remodeling, freeway remodeling. Nowadays, Caltrans, the state of California, or whoever's in charge, is supposed to prove that they recycle 40% of material. So you see a lot of rock crushing going on along the freeway. These are really good questions. By the way, I encourage any question that comes up. I may be able to have some answers for you. And if I cannot, the rest of this class or other people expertise, they bring it up. They be able to help me with the answers. Or if we cannot answer it, we'll ask ChatGPT or AI. I mentioned last week that AI is a part of this class. You're going to learn that. There's a lot of questions I don't have the answer. All right. We got a few more slides to show you, and that has to do with the fresh concrete, the soup. Significance of workability. You heard a little bit about that from me. Your soup needs to give you enough time, give your crew enough time so it doesn't harden too fast. Or it has to be at the right mixture for you to trawl it, to finish it, to acid wash it, to do a lot of things to make the aggregate expose. If you do not mix your concrete properly, you will have segregation. In other words, the elements don't glue very well with each other. You're going to have bleeding. Bleeding is where you finish concrete and the water shows on a surface. A good concrete, when you finish, it shouldn't bleed. It shouldn't have too much water in it. The terminology, I'll show you pictures, but the terminology of bleeding is important. Bleeding is where you have smoothed the concrete and you're towards the end of it and you see water surfacing, water coming to the top. Concrete, when it's finished, is heavier than water. Will soak to the bottom and water will want to come to the surface. If you have too much water or if you have vibrated your aggregate too much, it's like a soup that is too soupy. You blended too much, the aggregates broke down. They all went down. So you get a very soft top and a not very good strong concrete. Latence is another element. If the water comes to the surface, you see some white stuff on top of your concrete. Your concrete, you see that sometimes on your driveways after 5 or 6 years. Latence is that salty finish that comes to the surface of concrete. Then we get to the unit weight and air content. But first, workable concrete. These pictures show you what the workable concrete means. Concrete comes either from the machine, like that, on the right-hand side, if you're doing a roadway, concrete roadway, if you're doing a concrete tar pit for airport. That much of a concrete needs time for people to finish it. You can have concrete delivered, have only one man with a shovel standing by. You need to have a crew of 4 or 5 people to jump on it, finish it, trawl it, deliver it. So, workability is a significant part of your final product. You may have ordered the best concrete in the world. You may have spent the biggest money on your material. But if you don't have the right people and right workable concrete, does not provide enough time, and you're going to get a hodgepodge. You're going to get an unfinished product. So workability, when you tell the contractor or the batch plan, I want a concrete to pour for the slab, or I want a concrete that I can pour on the 50th floor of building. These are 2 different concrete with the 2 different workability. One concrete is going to be dumped with a gravity like what you see, no problem. The other concrete needs to be pumped. That concrete that gets pumped cannot have big rocks in it. Concrete that you use for a swimming pool cannot have big rocks in it because it is pneumatic concrete, is pushed by air. So those kind of concrete, even though I'm not talking about strength, I'm talking about workability. They all have to be high strength. But how you achieve high strength and different workability is a job for right mix and batch plan, knowing what you're doing. One of the indications of the good workable concrete is slump test, the slump ratio. This is the first test that they conduct when you bring concrete to the job site. I show you a video later on how a deputy inspector stays on the job, takes samples like this from each truck when they bring the concrete to the job site, puts it in a cone, shakes it, rod it. There's a technique to the madness. You gotta stir it, or you need to tamp it 30 or 4 times. Then when the concrete is in a cone, you reverse the cone and you use the cone to measure. If you reach 4 inch, the gap between the straight rod and the top of the concrete slump, 4 inch, that's a good concrete. In other words, concrete will slough off. As soon as you dump the green cone backwards, first you feel it, it has closed at the bottom, so the container becomes full of concrete. Then you rod it a few times to make sure it's the right mix, and then you lift it, you dump it slowly. When you dump it, any fresh concrete will slough off, but that sloughing should not be more than 4 inch. If that's what you get, that's job passes concrete slump test. This slide shows you 3 different slumps. The top does not measure 4 inch. That does not have enough water. No, I'm sorry, the top is a good one. No, the top doesn't have enough water. The second one has a 4 inch. The third one has got too much water, sloughs up. So a simple test is acceptable all over the world. It's called slump test.
So, Professor, just for clarification, you mean so you have the concrete and essentially it compacts or it reduces in length by 4 inches, or it starts actually pieces of it start falling off.
It doesn't fit. No, it's a water. As soon as you dump it, your soup, your mix, start losing water. If it has got too much water, it sloughs off completely, becomes like goes down. It's not right concrete. So look at these three pictures on the right-hand side. The first one does not shrink enough, shrink 2 inch. The second one, shrink 4 inch, adequate. The third one has got so much water, water dissipates, run off. And the material, the soup does not have enough beans in it. The soup does not have enough bulk to it.
I have a question. How long did the slump test take? I mean, do you flip it over and then immediately it slumps, or do
Yeah,
you wait
this
5 minutes, or?
no, this is pretty quick.
Okay.
The way it is supposed to be. Concrete truck comes in, and when they get to the project site, they roll their drum. The drum is not rolling in a freeway. You all have seen truck with the drum at the back in a freeway. The drum is solid as they travel, but when they get land to the job, they turn the drum once or twice to make sure the water and the aggregates they get remixed. Remember, all this has to be done within 1 hour, otherwise too late. After 1 hour, after the truck is ready to dump, they take off the chute. They fill this canister, this cones. Then the cone comes with the rod. You see that circular rod sitting on top of the cone? The technician is supposed to rod the mix 20 times to make sure it's mixed. And then they lift the cone, they dump it. They know they do it cautiously. I show you a video, you will see all this thing in actual timing and all that you get out of the video. This is just the beginning night introduction. But all you need to know, 4-inch slump test, good. There are a lot of studies done on workability of the concrete. There are a lot of curves that define water cement ratio, slump test, and temperature. Batch plans are good with this thing. I see Mr. Toledo just decided to join us. How are you doing, buddy? Can you hear me? Moises, you cannot hear me? No? Everybody hears me.
Can you hear me?
I can hear you now.
Oh, I can't get my headset to work. I couldn't log in earlier.
So you can hear me or no?
I can hear you now. I guess I'm just gonna have to use my speakers off my computer.
No problem. We're wrapping up this class tonight, but
Oh,
hang around.
I'm too late.
No problem. It's good that you came. Factor affecting workability. Obviously, the glue is the most important part, the cement. Aggregates. The grading of aggregates. The bigger rocks you have is less workable. If the rocks are too small, not good. But if the rocks are about 380 inch and larger, they are pretty good. Admixture. Workability can be improved by adding certain admixtures that delay setting time or reduce water requirement, resulting to the crews having more time to finish their concrete. Entrained air improves workability. Sebastian, somebody was asking about why do you put soap or air entrainment materials into concrete? Because as it has more air in it, it's easier to work it, smooth it, finish it. And also, if once it bleed, the water comes out of it faster, so you can mix the water so you don't get the water towards the end on the surface. This
One
gives you,
question, sorry,
go
Professor,
ahead.
one question about the slide about aggregates. So here it's saying that rounded particles. I thought we're avoiding rounded particles.
Correct.
But what do they mean here? They're saying like rounded particles will improve workability. Is it they're not talking about like those pebbles that you find in like a riverbed, are they? Are they talking
No,
about
no, no.
okay.
River rock is not good. The word is coarse aggregate, containing a flat or elongated piece leads to poor workability. That means when you get a coarse aggregate, you want really jagged shape. You don't want to get something that has a smooth or elongated piece. Because let's say you're trawling something. If you got a big piece of elongated, it's hard to blend it with the rest of your mix. Let's say you're dealing with a soup. The bold stuff, the big rock, you shouldn't see it in your concrete. You should see a good mix of uh, aggregates.
And I think what he's alluding to is that it says that a smooth improves workability. So workability and strength are two different things. If you're pouring flat work and you're trying to put a nice broom finish, well, broom would be cheap, but you're trying to put shiners and decorative things and you want to make a nice square cuts or whatever, you're not really looking for strength, you're looking for workability. And so when you have coarse aggregate, of course, it would be really difficult to get smooth finishes out of it with sharp pieces of aggregate.
Yeah. You want both. You want both strength and workability.
Mhm.
Depends on the scenario. If it's slab, workability may govern, maybe more paradigm. Here's an example of the cohesive concrete. You have three samples, A, B, and C. Indicate whether the concrete is harsh, sticky, or plasticky. A good plastic mixture is neither harsh or nor sticky. It will not segregate easy. Cohesiveness is not a function of slump. A very wet, high slump concrete lacks plasticity. So workability is affected by plasticity of the concrete. All three mixes were made at about 4-inch slump. So all this past the 4-inch slump. But you see, you can still get different workability, different kind of concrete for different uses. Example A is a coarse aggregate in a harsh mix. Example B is a good workable with a coarse aggregate is append in a mix. You see some coarser material, but does not separate easily and the surface can be trolled. So the middle one is better for surface finish, sidewalk finish, something that you want to troll smooth. The last one, C, is a sticky oversanded mix. That is good for the swimming pool, like a gonite, lacks coarse aggregate and does not have plasticity for good workability. So you have to apply with the pneumatic machine something quick. So basically, workability, as Matt said, should not be mixed, understood with strength. You always want strength, but it's different than when you use a slab on grade or a driveway versus a high-rise slab, floor for slab. Here's a good example of bleeding. When
Sorry,
you finish,
Professor.
bleeding.
I have a question with the previous slide.
Yeah,
So are you basically saying that like with these different types of concretes, they're all viable in terms of like
for
what
different
project you're gonna
purposes.
do?
Yeah, these are all
Okay.
available for different purposes. If you're
Okay.
doing, let's say, a dam structure, you may be able to use this because you need a lot of it. But if you are doing, let's say, a sidewalk or something that you want really smooth, you may go to this. If you want building, regular building, you may use this. This nothing to do with strength, has nothing to do with slump test. It's how much time it gives you to finish it, make it pretty.
Thank you.
New. Let's say you use this material in the middle and you did a concrete. As you throw the concrete towards the end, towards the last hour or half, you should not see shine, water is coming to the surface like that. A good concrete, when it's done, you see a concrete, you see it's not cured, but doesn't have a water or shine or water on top. This is an indication that there was a little too much water in here. After the concrete has been leveled off, surplus water in the concrete rises to the top surface of the concrete, accompanied by the slight settlement or solid particles. Could be salts in the water, could be salts attached to the rock, because all these mixtures that you do, there's some kind of a unrelated material in there that gets soaked by the water. Unfortunately, that is going to come to the surface, and that's called bleeding. So a good concrete, you should not see water coming like this on top. Another thing that you need to make sure your mix is right, when you put the rebar in concrete and you call it reinforced concrete, the concrete got to grab the rebar. So if you do not mix, if your aggregates are not dry, and you create holes like this or cavities underneath this is no bueno. So one thing is the concrete to be right mix. The other thing is paying special attention because you want a concrete to adhere to the rebar, to work harmonious with the rebar. If the rebar is not attached, this is where the rusting is going to happen. This is where the water is going to pile up. This is where the air is going to get entrapped. As a result, you're not going to have the strong reinforced concrete slab or building because you don't have the concrete has not grabbed hold of the steel properly, or this area is full of sand. So one thing they ask you to ask the contractors to do when they pour concrete, there is a vibrator that they use. They vibrate to make sure that these nooks and these holes, these areas, they don't become void. The key to the good reinforced concrete is the adherence of the concrete to all sides of rebar. Other elements that we will talk in this semester about, and I briefly touched upon it tonight, was weight of concrete. By now you know 150 pound a cubic feet, 110 pound a cubic feet, the differences. The unit weight of concrete is determined based on the unit weight of its aggregates. So utilization of the right aggregates, it gives you the proper weight, the unit weight. And remember, the unit weight had to do with how much water you mix. When we said 4 gallons of water needs to be mixed with the cement, you get a good glue. But if that glue, you do not apply it to the right material, the glue cannot keep it all together. Air content is the same thing too. You want air content in your concrete, but not too much. I talked about adding pozzolans or creating porous concrete, but not too much. So normally air content should be 1 to 2% in concrete. In train 8, maybe as high as 10%, but under huge control. There are 3 methods of determining the air content. You can weight the concrete and come up with. You can do a pressurized applied samples to it, or you can volumetrically measure and figure out based on that weight how much air is in the concrete. These gets into the laboratory testing and batch plant testing, but in wrapping up tonight's presentation, 5 major components to concrete: air and pozzolans and rebar. So you're talking about 7 different elements that they have to come together to produce a man-made product. Anytime you make a man-made product, quality assurance, quality control, huge. Batch plants, that's the job of batch plant. When a batch plant sell you a concrete truck for $2,000, for $2,500, that doesn't come cheap. They're selling you a bunch of rocks and sand and water and concrete mix. But what they're charging you is for their expertise on proper mix, buying proper aggregate weight, buying proper sand, buying, usually getting proper water, maintain their trucks to deliver the concrete on time. For all that, they make money. One concrete truck is $2,000, but if they sell 200 concrete trucks a day, you will see how the money is made. These are big boys. They make good money. Each concrete truck, we'll get to all this later on. Each concrete truck is worth at least $100,000 to $200,000 worth of just a truck. So we're talking about big business with a lot of control. Some of you, you never know, may work for a batch plant, may work for a testing company. Be prepared, but you're getting the first brush at it. Any question? I'm going to stop the recording at this time.